Hi all, I'm Thomas, Sales Director of Emerging Vision for the EMEA region. I'm happy to be here today and to guide you a little bit through our solutions for multi-camera applications. I think it's quite important to be here today. Just like the last 1.5 days, we had a lot of discussions with customers who are planning to have multi-camera applications or who are fighting since years to get a multi-camera application up and running safely. And there's still a lot of issues in the market, a lot of rumors in the market, and I hope to give you some insights today how you could get something like that up and running. I'm not talking only about 2 or 4 cameras, but talking about several 50, 100 cameras or even more, depending on your application you have. So we will start with a little marketing about ourselves. But I'll try to not waste too much time about that. I will give you a quick tour about the cameras we have from our side. I will talk about the challenges you might have faced already or you will face depending on what you plan to do when it comes to multi-camera applications. I give you an idea about how we solve issues with others still have in this market and what is coming up next, Vision 3.0. Maybe some of you have heard of that already with RDMA, Rocky V2. It's at the moment a big marketing thing for a lot of companies out there, so I will talk a little bit about that. I give you a quick tour in the end about how we handle then the data later, because it's always good to have all the data you need in the RAM, for example, in your memory, but what the heck you will do next to that, because normally if you talk about multi-cameras, you have a lot of bandwidth of data stream, and it's quite important that you also can safely process those data. And of course, last and not least, I give you an insight about how some of those applications might look like. A good thing for you, we have our booth directly there, so I will point quite often over there, so you can see some demos from our side also over there, which shows multi-camera in different applications in different ways. And of course, if you have any questions in the end, happy to answer those. So about us, we are a Canadian-based company. I'm from Germany, you maybe noticed that already with my English, I cannot hide that. We are based close to Vancouver, in the suburbs of Vancouver. We were founded in 2007. Our founder is still our CTO and owner of the company, which gives you maybe an idea about how engineering driven we are. We were the first with 10 gig E cameras more than 10 years ago. We were the first with 25 gig E cameras more than 5 years ago. And we have now since 3.5-ish years also 100 gig E cameras in the market, which means every time when there's a new sensor which needs more bandwidth, we are able to more or less increase the speed of the interface we are using. We are absolutely leading in the market area of high-speed gigabit Ethernet, but we have only gigabit Ethernet, which I will show you later, gives you also some advantages. And as I said, completely fully family-owned, which makes us also independent in our decisions, so we don't have to follow any decisions from any big other company. Coming to the cameras we have, as I said, we have 10, 25, and 100 gig E since a while. We have area scan, we have line scan cameras, everything available. We have now brand new our Aeros family, which is here still as a 5 gig E camera named. We changed that in the meantime. So over there we have them up and running. It's now the smallest, lightest, and more power saving 10 gig E camera you can find in the market, but more about that also later. They all support our technology, which we name zero copy, zero loss, which gives you maybe an idea already about what I'm talking a little bit. And of course, we are also supporting technologies like GPU Direct, which is quite important when it comes for processing of the data. Area scan, let's say we have all cameras, all sensors available, which you normally have from Sony and from G-Pixel. 4th, 3rd, 2nd generation from Sony. G-Pixel we use mostly for high speed and of course also for line scan, for our line scan cameras. There we have the 4K, 8K, 9K TDI sensors and 60K sensors. And everything which I explain now in the end is more or less capable to do with all of those cameras. So if you go lower speed, if you go higher speed, whatever I explain, it will be possible also going in multi-camera applications. Hello? Oh, wrong, sorry. That's now again the arrows. Just to give you a small insight, it's a 29 by 29 millimeter camera, standard design, which you normally use, for example, for 1 gig E or sometimes for 2.5 or 5 gig E. This baby is now ready to go for 10 gig E. It's available with PoE, so with RG45. It is available with an LC interface, so with fiber interface. The absolutely amazing and market-leading topic is power consumption. We talk for the fiber version, we talk of 3 watt only. It depends, of course, on the sensors inside, but this was done with a 20 megapixel sensor from Sony. And even with PoE, we need only 4.8 watt. It gives you maybe also an idea when it comes to heat consumption, the heat issue of high-speed cameras. Those cameras, they are running, as I said, at our booth. You can try it, you can basically touch them. They have no active cooling, they have no special cooling function in our demonstration. They are getting warm, but they are much better than everything else you can find in this market. And I said, if you have an application where you need low power consumption, 3 watt is maybe something which might be interesting for you. This guy is a good example of the people we mostly meet the first time. So when we have discussions with new customers who are working or trying to work in multi-camera application, this is mostly what we hear from them. They tried several years, they tried several months, they tried several suppliers, manufacturers, and they always failed. They have frame loss, they have frame drops, the system is not running stable, they don't understand why this is happening, and they don't have a solution for that at the moment. And mostly the solution is that they just spend more money on the hardware. So instead of using, for example, 1 workstation or 2 workstations for a big amount of cameras, they use several workstations for only 2 or 3 cameras, because otherwise they don't get it into a stable manner. So as we name it, it's not really a good hit. To solve your issues. One of the reasons, if you talk about gigabit Ethernet, why this is happening, and which is still in the mind of a lot of people, is the very traditional and conventional way how you do things. So this is how a lot of people still do gig vision inside the cameras or as inside their software. So they use the CPU and the RAM for more or less building the frame together again on the PC side, which means you transfer the data out of the network card into the memory. From there, use the CPU for reconstruction of the frames, of the packets, and then you go back into the memory to have your full frame ready, more or less, for whatever you plan to do with that, which increases dramatically the workload of the CPU and of the memory, which means it's good for 1 camera, it's good for maybe 2 cameras, but if you ramp this up to 3, 4, 5, 6 cameras, you easily ends up in the end of what a standard PC is capable of handling, and then you get into your hiccups, which ends up in frame drops and so on, so maybe something you faced before. What we do since ages, honestly for us, because as I said, 10 gig E we do since more than 10 years in the meantime, we are fully GigaVision compliant. We use GigaVision streaming protocol, which is part of the standard. But we have optimized everything. So we named this True Zero Copy, and maybe something you heard before is full kernel bypass, which means we use the network cards, off-the-shelf network cards, so nothing special, network cards you can buy free in the market, and we do more or less the complete construction on the network card, and then directly transfer it from there, for example, into the memory, or as I mentioned before, for example, directly into the GPU. So wherever you need the data, where you want to have the data, we can actually transfer it to that location, which reduces extremely the stress level of the CPU. So, and the memory, of course, the bandwidth we need of the memory. So we have over there, for example, 36 10 megapixel cameras running with 12 megapixel each. They are all synchronized. They are running into 1 switch. From this 1 switch, the bandwidths are running through 4 100 gig E fiber cables into 1 workstation. And there's 1 GPU who are doing 3D reconstruction, in this case as a demo, without any frame drops, without any loss. And the CPU is more or less idling in the background with 12% or something like that. So quite low CPU load we reach through that. So maybe quite a good hit for when it comes to multi-camera applications. As I said, the network cards are off the shelf. So we work together with Mellanox, now NVIDIA since a while. We work together with Broadcom, for example. And of course, as an example, we have also our own network cards, because we have some features which are good for the industrial market, but maybe not used in the standard data interface networks constructions, and that's why we have also our own network cards, but you're completely free and up to you which of those network cards you plan to use. Now it comes to the system design and integration. It depends, of course, a little bit if you talk about a higher amount of cameras, if we talk about a lower amount of cameras you want to use. If we talk about little densities, let's say 2, 4, 6, 8 cameras, normally you can directly go into the network card, for example. You can use it, as you see here, a quad port or a dual port network cards. You can use then, for example, a trigger port at the network card, which you maybe used from QuarkXpress if you used that before, to trigger and sync the cameras. Or you use, of course, the GPIO port of the camera for triggering the camera, hardware trigger the camera directly there. Or if you go high density, what we do on our booth is, for example, you have several 10, 20, 30, 50, 100 cameras. There you go first into a switch. The switch you can also use for PTP, which improves a lot dramatically synchronization rate and triggering. And then you go from there with a 100 gig E, for example, depending on the amount of cameras, NIC into the workstation or into the server. And then depending on what you want to do, this is now showing a little rate system, because we have also a lot of customers who want to first record what they stream from the cameras and then more or less post-process those data later. But of course, you can also put this directly into a GPU for post-processing and so on. And then for integrating our cameras, as usual in this market, we have, of course, an SDK set. It's free of charge when you buy our cameras, which helps to integrate our cameras into your software. And of course, let's say for the first steps, we have a eCapture Pro system, which is a quite nice tool for multi-camera recording. You can program the cameras, you can change the settings of the cameras. You can also take a look in that later on our booth if you like. It's a graphical-based interface, quite handsome. Even I can use that, so it should be a good tool. And as I said, maybe also something quite important is, as I said, what you do with the data after you have it in your memory. Because a lot of, let's say, people, they take care that you have the data in your memory, but they leave you alone when it comes to how to process those data. If you don't want to do with a CPU, you can, as I said, use GPU Direct. Not sure if most of you know that. It more or less enables you that you can directly send data stream from the network card directly into the GPU, which means you bypass completely your memory. You can do this with one NIC GPU, you can do this with several GPUs, that's all possible, which also is capable of doing, for example, with NVIDIA NICs, RTX, NVIDIA NICs GPUs, sorry, from NVIDIA. Or you can use for the high-end applications, we have a few customers doing that in the meantime, you can directly use an FPGA card. There's, for example, from AMD and from Xilinx is the Alveo card, which is giving you the possibilities that you can directly use the fiber interface and directly go from the cameras into this FPGA card, and then you can use the FPGA power to do whatever you like to do. It's maybe a little bit more complicated. You have to know how to program FPGA, but if you're good to that, it's more or less really the high-end solution we can offer. Then, as I said before, big thing at the moment marketing-wise, I think also Lucid will talk a little bit more about that in a few minutes, so I don't want to talk too much about that. Which is coming up is GigE-Vision 3.0, so it's the new next standard for GigE-Vision. The new big thing for a lot of our competitors who are using the traditional way is that there will be RDMA and RockEV2 included, which is maybe important for you is to know. It will do a lot of things very similar, like we do it since a while. It helps to make the systems in the market more compatible with each other, which is good, of course, for you on the customer base. But it doesn't support some of the features we support at the moment. From the beginning, it might be integrated later on, like GPU Direct via Windows might be a critical topic in the beginning using RDMA. But the good thing for you is we are supporting that already now. We have a demo of GigE-Vision compliant camera running at 100 gig E at our booth over there also. And you will have with us, you can choose freely in the future what you want to do. So we will go with you together through your spec requirements. We'll check what you really need. But I think one of the biggest and most important topics today is we are compliant to that. We will follow this standard, of course. It's a must for us. And we can guarantee you, doesn't matter how much cameras you plan to use, that you will have no frame drops also in the future, which is, I guess, the most important topic. And this small animation shows, for example, what we can do already now, so that we can process your data from wherever it's coming in a big amount of different possibilities. So here you can see we have this also as a running demo up there. You can see 8 cameras. They are 25 gig E cameras. They stream into one switch. From the one switch, we go into the first workstation. There, 2 GPUs are processing the data, next one after another. Then we send the data from one workstation to the other. And there, another 2 GPUs are working on the same signal run. So we stream the data from, again, more or less from the 3rd GPU into the 4th GPU. And then you have your complete output. So there are a lot of different ways how you can handle and process the data you get from the cameras. Last sentence, because I heard it here on the stage also yesterday, there is still, from a lot of companies who are using the old technology, I would say, the traditional way of using GigaVision, that GigaVision above 5 gig E is not stable, especially not for multi-camera. Take a look, because seeing is believing. We have a lot of demos up there out under our booth. We show it since years that multi-camera applications is possible with 25 gig E. We have applications with up to 100 cameras running simultaneously, fully synced into 2-3 workstations, doing whatever the customers want. So it's possible already now. And if you have troubles with that in your applications or in your future applications, feel free to come over. Thank you.